Here's a quick example of a probability problem that is not as bad as it first appears. Here we've got an unfair pair of dice. Unfair pair of dice in which here's all the possible combinations with dice 1 and dice 2, in which anything above this particular diagonal, this is where your totals are 7, anything above this is 5 times as likely to occur as anything on that column, and anything below is 2 times as likely to occur as anything on that column. The trick here is to make sure that you're discussing every possible outcome. In this case, as we've seen in the book and in class, by listing in this grid where we've got 6 by 6 grid, we've listed every possible outcome of rolling those 2 dice. And now it's just a matter of trying to determine those probabilities. We've got 36 possible outcomes here. And if we were to list all the probabilities, say 2, 3, 4 through 12, if we were to list all of these possibilities and then assign probabilities to each, all these probabilities should add to 1. But if each of these possible squares here is the same probability, each square in this upper triangle, lower triangle, and diagonal in each of those groups is equally likely to occur, and they've got these relationships to the probability of getting 7, we could say the probability of rolling a 7 is x, our unknown, and the probability of rolling greater than a 7 is going to be twice x, so 2x, and the probability of rolling less than a 7 is going to be 5x. If you use this table above, we need to know that there's only one way to get a 2, 2 ways to get a 3, 3, 4, 5 ways to get a 6, and so on. 5, 4, 3, 2, 1 above. So we've got the 3 different probabilities. We've got the 7, we've got greater than 7, and less than 7. Each of which, if we add up all those probabilities, should add to 1. So now plugging in our values, how many, we can count the number of outcomes that add to 7. Right? There's 6 outcomes that add to 7. So 6 times its associated probability, which is x, the number that add to greater than 7. That's 5 plus 4, 3, 2, and 1, or 15. And that probability is 2x. And the number that add to less than 7, again, is 15, with associated probability of 5x. By solving this, or 111, x equals 1, and x, which recall was the probability of rolling a 7, is 1 out of 111. Of course, then we can realize the probability of getting greater than 7. It's 2x, so 2 out of 111. And the probability of rolling less than 7 is 5x, or 5 out of 111. Then we can fill in this chart here relative to the number of ways that we could achieve each of these. So the probability of rolling a 7 is 1 out of 11. That could happen in 6 different ways. So 6 out of 111. Probability of greater than 7 is 2 out of 11. There's 5 ways this could occur. So 10 out of 111, 8 out of 111, 6, 4, and 2. Similarly over here, the probability of getting less than 7 is 5 out of 111. So 5 out of 111, there's only one way that can occur. There's 2 ways we can get 3, so 10, 2 times 5 out of 111, 15, 20, and was it 5 times 5? 25 out of 111. We should be able to add up each of these numbers. So we've got 6 plus 6, that's 12. So that's 12 plus 8 is 20. 36 plus 25 is 61. 81. Let's just say 91 plus 20 is 111. So if we add up each of these, we get 1, or 111 over 111. Okay. So to answer the question, the original question here, what's the probability of rolling a 7? That's the easy answer. Filling out this probability distribution table is a little bit more complicated, but can be done with really just a little bit of algebra. As usual, if you have any questions, please let me know.